Well, try to, first of all, share my screen again. And of course, I have to thank you guys for inviting me in this venue to present part of my work that was conducted in the last few years. I joined UC Davis 2013, and 13, 14, 15 were drought. And there was a double drought because it was a drought, physical drought, the start of upcoming environmental regulations. And then there was a drought of people because all the other irrigation specialists retired. And so they left me California, the full state to, I would say, to learn from. And so it was a kind of a, steep learning curve, but I'm pretty happy of the work that was done in the last few years. So I thought about presenting a couple of projects of applied research that I was leading or I was part of the team to show ways that we could probably enhance the agricultural water management, and those were mainly focusing on specialty crops. And specialty crops are pretty important in California in terms of income. So let me put in a presentation mode because I always forget. So I plan to give a few background information on California agriculture and water. Touch a little bit upon the trends, the long-term trends and water-related implication, and then start describing what we did to improve agricultural water management for specialty crops, especially focusing on one project that took about probably 5 to 6 years to start and finish. And that was the project on updating the information on water use of micro-irrigated pistachio. And the second project I would like to talk about is the evaluation of forecast reference evapotranspiration, a product by the National Weather Service that is called FRET. And that piece of work will allow some prospective irrigation scheduling. And I'll touch upon the concept of prospective. And then if I have time, I'll describe some upcoming work, the work that we just started as a follow-up of these two projects. Just a few numbers and figures to describe California agriculture in terms of economics. As you can see here, this table describes somehow the cash income generated in 2019, and it was taken from the USDA CDFA Ag report. It's an annual report. As you can see, the total income generated by California agriculture in 2019 was 52.6 billion, and here you have somehow the cash income broken down by commodity group, and fruit and nut crops are the first commodity in economic terms, generating almost 41% of the total cash income. And then livestock, poultry and products, vegetable crops, field crops, and all the other source of income. But this is just to say that fruit and nut crops in California, and especially in the San Joaquin Valley, really are a top tier economic cash income crop. Here is a map of the main agricultural production area throughout the state of California. The area in yellow, highlighted in yellow, is the San Joaquin Valley, and this is really a kind of a powerhouse of agricultural production, because 7 out of the 10 agricultural counties in California are located in the San Joaquin Valley, in this yellow area. And it's also called the fruit basket of the world. And alone, the San Joaquin Valley, this central part of the state of California, generate almost 60% of the total California agricultural income. Now, the state of California is also has some other records that are not necessarily good records. Is the top, is the #1 state in the nation for agricultural water usage. And this is related to the intensity of agriculture and also to the acreage and availability of farmland that produce a variety of different crops. We are almost slightly over 400 different crops throughout the state. In terms of, the top irrigated land use by acreage is again fruit and nut orchards and vineyards. Now, when we talk about long-term trends, this in the last 40 years, irrigated agriculture has been concentrating and intensifying, concentrating, in 3 specific areas: the San Joaquin Valley, the Sacramento-San Joaquin Delta, and the Imperial. Now, these areas, production areas, allow somehow intensification because they have kind of a more secure water than many other production area in the state. The San Joaquin Valley has the groundwater. The Bay Delta area as somehow the surface water, and the low desert and the Imperial Valley as somehow more secure water than any other production areas in California, thanks to the Colorado River Basin. Now, these 3 production areas generate almost 35% of the U.S. table food on 1.2% of the U.S. farmland. And that gives you somehow the magnitude of the production and the intensity of the production of these 3 areas combined. As I mentioned, in these 3 production areas, the cropping pattern are really intensifying with a clear conversion from annual to perennial crop, mainly fruit, nuts, and vineyards. We saw, much higher planting density, and this new orchards and vineyards require a lot more inputs, and that means water and nutrients. And there's a clear shift from surface irrigation method to micro irrigation method because the amount of water that could be used beneficially by the crop with this more precise and more localized irrigation method allows a better water productivity, so more crop per drop. When it comes to, let me move this, I always get confused with the with the Zoom. When it comes to the other factor, the intensification is being somehow fostered or promoted through incentives from federal and state funding program toward a more productive, more intensive irrigated agriculture. The other trend is that water agency and regulators are promoting a shift from different irrigation method, mainly surface irrigation method and sprinkler, to micro irrigation. And this somehow is misconception, and micro irrigation uses less water, but the purpose of shifting to micro irrigation was mainly for water conservation purposes. And this happened through federal and state financial incentive. So growers reacted to this financial incentives following the push and moving to micro irrigated crops, but also they shifted from annual field crops to permanent crops, and also they expanded the acreage planted in order to maximize net profit. But this resulted for sure not in a net water saving. These are results from a periodic survey of irrigation method that is normally used to be conducted every 10 years, but now is conducted every 5 years jointly by the Department of Water Resources and UC Davis, and this is a result of the last irrigation method survey. You can see here in this graph on the left, a clear, sharp decline of a gravity irrigation method in the black. They moved during the last 40 years, 50 years from 80% to 30%. And the difference being picked up by drip, basically drip and micro. Sprinkler methods stay pretty much constant, and it tended to decline, especially in the last few years due to energy-related aspects and also water-related aspects. And then subsurface irrigation somehow picked up a little bit from 3 to 7% in the last 10 years. On the other side, as I was describing, there's a clear shift from field crops over the years towards more orchards and vineyards, as I was mentioning, for maximizing the net profit. Vegetables stay pretty much the same, and all the other crop increased a little bit, but the sharp decline is for field crop, and the sharp increase is for orchards and vineyards. All this new situation with drip irrigated orchards and vineyards require more precise and also skilled irrigation scheduling and management. So here the value at stake are much higher, and so with water, basically farmer can be very profitable in their activity, but also the risk is pretty high. And so if they don't have enough water or they mismanage the water, there's clear consequences in terms of yield and quality of the production. Now, in this context, the rationale for optimal irrigation management has been in California traditionally to irrigate, trying to meet the crop consumptive use. And so this is basically what we call crop evapotranspiration. So with irrigation, we try to match the amount of water that the crop will use under no water limitation, trying to avoid water stress. And so this is basically what we consider when we have to schedule irrigation or schedule the delivery by water district to different areas or different production areas within a service area. So under well water conditions, so that means no water stress, we normally in California estimate the crop consumptive use, crop evapotranspiration, as a product of reference evapotranspiration, which is referred to grass. So the amount of water used by grass under no water limitation, under no agronomic constraint, multiplied by an adjustment coefficient, which is called crop coefficient. And then reversing this equation, solving for the crop coefficient, you can get a crop coefficient by dividing the crop evapotranspiration by the reference evapotranspiration. Now, this is a common terminology for irrigation people and for water people, normally for the water balance that we normally run. But now there are two components here. One is trying to get a good estimate or a good measurement of the reference evapotranspiration, and then trying to have good value and reliable and accurate value of the crop coefficient. For what concern reference evapotranspiration in California, we normally rely on the CIMIS weather network. Is a network of automated weather station that pretty much 152 weather station distributed throughout the state, not regularly distributed, but mostly in the concentrated in the agricultural production area. Their point station as the one that you see in the picture in the corner here, but also CIMIS has generated additional product with a spatial CIMIS, and this is an interpolated basically surface of reference CT that is available from the Department of Water Resources. So if your farm is located not in the vicinity of an automated weather station, you can still get pretty much reliable information by clicking on those maps that are interactive and can give you value of reference evapotranspiration. There's also a new product, relatively new, that was developed by the National Weather Service together with DWR and UC Davis. Is called FRET. As you can see, FRET stands for Forecast ET. And so you can have forecast of a reference evapotranspiration up to 7 days ahead. And there's having the possibility to anticipate what will be the atmospheric water demand helps a lot in scheduling irrigation and in scheduling water delivery for water district, but also anticipating the water demand for 7 days ahead. Now, the question now becomes, how accurate are the crop coefficient in California? Because they mostly were developed during the last 30, 40 years. And the question is, are they still valid under the extremely dry and intensifying condition that we have now for the different production area? Is still a pending question mark. Now, in terms of available information on crop water use, as I was mentioning, the studies on ET and crop coefficient for the different permanent crops and field crops in California were mostly done during the 70s or the 80s with methods that are pretty laborious, like lysimeter studies, or try to infer indirectly the amount of water used by the crop by keeping track of or monitoring the soil water through neutron probe reading, or sometimes the crop coefficient were developed just by educated guess, by expert. Anyway, those studies were normally conducted during the past 30 to 40 years for cropping system and irrigation method that are were very different with respect to what we have now. Because now we have new rootstock, new crop varieties, higher planting density. There are different canopy management practices, especially for orchards and vineyards. We have drip irrigation, which is spoon feed water and nutrient to the crop. And so basically, this is a different water regime for the plants. And also crops are now growing in areas that have marginal soil or have non-uniform soil. So there's a lot of spatial variability. But the main factor here is that the crop now have a much higher yield than, the crop of 30, 40 years ago for a variety of reasons. And so those crops probably have a different water requirement with respect to what was defined during the study during the 70s, 80s, and 90s. There's also some other factors. Some crops were less important in the past, and now they largely expanded in acreage, or they're grown under different conditions and they're not uniform. One of these is citrus, that now we have different mandarin and hybrid varieties that are being planted with higher planting density. The canopy size is very different from the past, and there's a variety of pruning practices, and also they're planting with different row orientation. Pistachio is another example. Is now grown on different rootstock with respect to the past, and is mostly, there's a expanding acreage on salt-affected soils, and before those marginal soils were not even used or used by other crops. Wine grapes is another example. Now we have a lot of wine grapes planted on sloping ground, on hillside, and they're planted with different, aspects with respect to the north-south or east-west, and south-facing, north-facing. And so there's a lot more to know about the crop water use. Table grapes and raisins, another example, that we got different trellis we got T-shaped or Y-shaped, or the gobble, higher low trellis, or California sprawl. So there's so much now and it's so different with respect to the past that make us question about the crop coefficient that were developed for different cropping system in the past. Now, there's a clear need for updating the crop coefficient and the information on crop water use, but at on-farm level for a variety of reasons, mostly for scheduling irrigation or for anticipating what will be the amount of water that is needed. Also, I'm back.
Welcome back.
I'm
Good
sorry.
morning.
I'm sorry. Sometimes, it's connection not very steady. Can you see now? Can you see back my screen?
Yeah, perfect. We're
All right,
back.
all right. There's also, at the farm level, there's also the need to know if we can maintain or can even expand the planted acreage in the specific areas, or we need to shrink, we need to retire some planted areas. And as that, there's also a prospect for increasing drought occurrence and more severe drought occurrence. So I think at a farm level, it's also, knowing that crop water use is also important to design and implement deficit irrigation strategy. At the off-farm level, there's a variety of reasons why, better knowledge of crop water requirements of crop water use is important, and compliance with existing regulation or for moving water between hydrologic region with water transfer or water market, but also there's other purposes like to design financial incentives and also for estimating the economic water productivity of crops. So those are a set of reasons why we should probably know better how much water is used by the different crop under the current cropping condition. Now, on the weather side, as I mentioned, on the reference ET side, I wanted to describe a little bit of this forecast ET because it's a pretty interesting as a product to anticipate the atmospheric water demand 7 days ahead. This is a new product, developed by the National Weather Service together with UC Davis and DWR. And this was developed for improving, high frequency irrigation management. So basically micro irrigation management, and also encourage and foster the adoption of ET-based irrigation schedule in California. FRET forecast, reference ET forecast are now available up to 7 days ahead. So you can have 1, 2, 3, 5, and 7 days ahead forecast, and it's available for the entire continental U.S. And this is the way the FRET table used to look like. Now the National Weather Service transfer everything into maps, and it's a little bit more difficult to download values for the next 7 days ahead, but I'll show you how it looks like now. We are pushing to get back on the table because growers were used this type of table pretty much up to probably 6 months ago. And when this table disappear, it's kind of a damage for them because the maps are not so straightforward. And then they need, here is how it looks like for the entire continental United States. And you can see the different intensities of color with a scale on top of it. And this is a little bit more detailed map or Visalia, Porterville, so the southern Joaquin Valley. And you can see now you can call also some table out of this map, but it's a less straightforward than it was in the past. Now, reference ET, when we get it from CIMMYS, are considered somehow, are described as near real-time information on reference ET. But in reality, they are retrospective. And so they are referred to the period that has just passed. And so when it comes to schedule on farm irrigation, this is a little bit limiting, and I'll show you why. So when you look at the past days, and you want to use ET data from the few days that are just past, either 1 or 3 days or 1 week or 2 weeks that are past, when we use these values to schedule water delivery to growers or irrigation, then there is some problems, and I'll show you. For many locations, in fact, in California, there are periods there, the weather conditions are pretty much changing on a daily basis, or every 2 days, 2-3 days, or from week to week. And this is an example from Napa Valley, for instance, in the northern coast. And you can see April, May, and June. This is a 3-day cumulative reference ET. This is what normally is used for scheduling irrigation in grapes in the Napa Valley. And you can see here, look, 3 days, from 3 days to the next 3 days, how much the weather is changing in different parts of the crop season. And when this happens in periods that are pretty sensitive, either water excess or water shortage, then using the data from the past days to schedule irrigation for the next week, then you run the risk of carrying forward errors and mistakes. See here, another example again for Napa Valley for September, the end of the growing season for grapes, which is pretty important for the determination of the yield for the subsequent season. Even here, you got the weather that's pretty much changing from one period to the next. Every 2 or 3 days, it changed quite a bit, and you can see how much is the fluctuation. Now, this area is exposed to the ocean income through the Bay Delta, but this is not the only example in California where there's a lot of variation from day to day or every 2-3 days. When we come to the 7 days cumulative reference ET, again, see how much is the difference from 1 week to the next. So if we use last week ET to schedule next week irrigation, there's a big risk of going under or above. And so we run the risk of over irrigating or under irrigating. And this is pretty dangerous for certain crops when it is important to schedule water, the application of water precisely for fruit quality or for yield determination for the next season. Now, forecast ET, FRET, forecast basically all the weather variables. Here is an equation for calculating the reference ET. Is the most widely used equation is the FAO Penman-Monteith. And so you see a bunch of parameters here. Now, FRET forecast almost all the weather variables that are inputted in this equation, and they are needed for calculation of reference ET. The only exception is the solar radiation, which is calculated from the forecast daily fraction cloud cover. So it's basically calculated based on the ratio between the actual and the potential sunshine hours. But other than the radiation, all the other parameters are forecast by this global forecast system or GFS model. Now, we conducted in 2020 a validation work to see whether FRET is somehow reliable or match the ET estimate that we got from observed value at the CIMIS station. So we selected 15 CIMIS locations in California that are showing this map on the right. And here are the location with the number of the station and the reference ET zone and the type of climate that are typical in this area. So those stations were selected randomly throughout California in order to cover different climatic zone and different type of climate. And what we did, we compared what we got from the FRET forecast for the different weather values, weather variables, against what we got from CIMIS in order to assess whether the FRET weather variable were estimated accurately. And then as a second step, we compared the forecast reference ET for 1, 3, 5, and 7 days against the ET calculated from CIMIS weather data. What we did is somehow try to understand whether the forecast ET were dependable and accurate, assuming that the CIMIS reference ET is accurate. Now, here's the results that we got from June. We did for 3 central months of the growing season, June, July, and August. And here you can see the one-to-one line and the R-square and also the regression equation between FRET on the x-axis and CIMIS reference ET. So in June, the values are pretty much matching. Besides, some of the stations that are somehow off, and I'll explain to you why. And we did this validation for lower reference ET, medium reference ET, and high reference ET, like 5 Points or Davis or Shafter. All these stations are somehow either in the Sacramento Valley or the San Joaquin Valley. We did this for the 1, 3, 5, and 7 days. I'm just showing graphs that are selected just for the sake of time, but also for 7 days ahead, the situation is somehow pretty good in terms of values that are matching. So the forecasted value are matching the measured value. And we did the same for July, and we did the same for August. And you can see there, the data that are forecast by the National Weather Service can be used somehow reliably by farmers in order to simplify the irrigation schedule, but it can also be used by irrigation district and water district to anticipate the water delivery or the water needs that have to be met in the different area of the common service area of the district. Now, this is everything together, and somehow we developed some statistics in order to understand the root mean square error and the coefficient of determination for 1, 3, 5, and 7 days for the different station. And you can see there that the values of the RMSE and R-square are pretty reliable. And so this means the growers in this production area somehow can use this type of information in order to anticipate the water demand. On FRET, some conclusive remark. So the comparison between FRET forecast ET and CIMIS ET, and CIMIS ET was calculated from observed weather variable, shows some good agreement for all the 15 selected station location. And those station location, again, span from moderate, so from low to moderate ET to high ET demand. The results also show that the 7 days reference ET forecasted are somehow nearly as good as a 1 day. And this is somehow counterintuitive. When the forecast is a short term, we expect to be more accurate. But in this case, the 7 days nearly as accurate as a one-day forecast, and that is pretty comforting. Considering all the data together, R-square range between 0.9 and 1, and the RMMSE was mostly less than 1 millimeter per day, that corresponds to 0.04 inches per day. So the error or inaccuracy with respect to CIMMYS was pretty negligible. Poorest results in this validation work were obtained for in station. There's somehow in peculiar climatic areas like Meadowland in Imperial Valley. This is a low desert. There's a lot of advection, and so somehow the results were not very steady and not very dependable. Torrey Pines is in the San Diego area, so there's a lot of ocean air inflow in that area that makes the prediction probably of the net radiation or the solar radiation a little bit more unreliable. Also, it's very difficult to predict wind coming from the ocean. And the other was Camino in the El Dorado County, and this is surrounded by forest. And so also here, the forecast of the radiation was probably poor. And there was some slight overestimate in some areas of forecast ET versus CIMMYS ET in some other mountain range, or in Napa Valley. In Napa Valley, there was some misfunctioning of the CIMMYS station, and so that station in 2019 was discontinued in operation for a month or so, and that somehow made the comparison pretty difficult. But anyway, FRET, after this validation work, we concluded that FRET reference ET, so the forecast reference ET, is pretty reliable. It can help growers to somehow schedule irrigation for micro-irrigated crop, pretty reliable with respect to CIMMYS as alternative to CIMMYS. Now, the cost of CIMMYS is pretty high in California. And so if a validation work for the entire number of the stations of CIMMYS is done pretty accurately, then it means that it doesn't have to be maintained. Although the CIMMYS network is, also the fruit of a large investment and almost 30 years of operations, being used by a variety of users, not only irrigators or farmers or ranchers, but also IPM. And so there's multiple uses. And so anyway, FRET is pretty reliable in the station where it was tested and can be used as a forecast. This piece of work was the results of this work was published in a recent publication, and you can get all the information about the type of data analysis, the type of processing that we did by checking on this article. A few links here, where to get information about CIMMYS, where to get information about spatial CIMMYS, and where to get the ET data from the National Weather Service in terms of weather forecast. Now, with that, I probably should not go too much into the detail of the crop water use because for the sake of time, it's already 45 after. So I just want to mention that in the last 6 years, I was part of a team that conducted a variety of field research studies to improve irrigation management of permanent crops. The first crop was pistachio. So we did I would say a 5 to 6 year project with a lot of measurement in the field to update information on ET and crop coefficient of pistachio grown on non-saline and salt-affected soils in the San Joaquin Valley. The second project that I was part of was trying to understand the effect of topography and the training system of the vines on the vineyard water use, because evapotranspiration is an energy related process, and so depending on your slope and aspect, you can intercept more or less radiation, or you can intercept other source of energy like wind or masses of hot or cold air. So the topography and the aspect of the vineyard is pretty important and can generate significantly different values of crop water use. And we did this project both in California and in the Central Valley of Chile, and the results have been published and are being published for the Chilean situation in an upcoming article. The third project that I was part of the team is related to citrus, and so we measure the amount of water somehow used by mandarin and navel orange in the San Joaquin Valley, in the eastern side of the San Joaquin Valley, as a function of canopy size and row orientation. And that was the third project that I probably would like to describe maybe in another talk. But there's a variety of ongoing research being done, and this culminated in a crop coefficient committee that we established in 2018 with the DWR in order to analyze all the data that were field data that were collected during the last 15 years by the different scientists and researchers, and in order to make it available for California growers and water district GSA. And this was a water smart project that we're about to start in March, and will allow to somehow update the information on actual water use and consumptive water use of the top 10 most water demanding crop in California. With that, I'll probably stop here, and I will be happy to entertain questions if you guys have.
Thanks, Daniele. That was awesome. You covered so many things. So I think we have some questions in the chat. So let's go one by one. Okay, so there's a question on the forecast reference ET. The question is, with weather changing, climate change influence. So kind of a comment on the stationarity concept. And the question is, how reliable the FRET data is.
Well, I think the modeling capability of FRET is somehow not based on the past trends, and so the stationarity hypothesis is not considered, is not what I'm trying to say is that the forecasting model is not built on the previous data, but is built on the possibility to anticipate the weather variable on the basis of other algorithms, but not based on past data. And so I don't think is gonna be affected by the extreme weather variability. And as we showed, in 2019 was a good water year, but at the same time, FRET was able to anticipate the or to forecast the clear weather variation from even in the short term. So I don't think the model, but you have to ask a climatologist. Probably is better expertise to ask this question, but I don't think the model is based on past trends and past data to anticipate, because those are short time forecasts, up to 7 days. Now, I know that the U.S. Bureau of Reclamation has been working in the past 3 years on another model. Is able to forecast on a monthly basis, and that probably is a model that is built on somehow past data or historical data at the different sim station. Yes, but this is a good question. But
I mean, is it fair to say that our ability to forecast is kind of getting hard and hard because of the changing weather patterns due to climate change, right?
Yeah, but the computational ability is also becoming refined and refined and refined. And so there's a multiple algorithms and and calculation procedure that you can input in the new modeling. And so I think it's true that the situation is becoming a little bit more and more and more difficult to anticipate or to forecast, but also the computational ability is becoming better and better. And so, especially with the climatic data and weather data. Yeah.
Good point. Good point. Yeah. So next question is, what's your take on OpenET? Could it be more reliable source for ET because it is integrating the impact of new crop varieties on ET through satellite data?
Okay, my take on OpenET is to wait and see and let the scientists work in order to refine the estimate. The first shots were not really encouraging. We noticed we're measuring ET on several crops with the edit covariance and surface renewal technique. And when we compare ET estimate by OpenET, basically the difference were pretty large in terms of 40–50% plus and minus. But I would say this was the first shot, and I will leave the scientists work and refine what they have. And I think a little bit more ground truthing is needed for this models, because this is a blend of an ensemble of 4 to 5 models, and probably they need to calibrate and validate some of the modeling effort a little bit better into the different conditions where the crops are grown. And so I expect the OpenET to provide reliable information, but it might take time. It might take some time.
Yeah, and this next one is rather a comment on, I think you said something about CIMMYS data reliability. So there's a comment here that says, I know that Camino station has no irrigation for the grass. Tried to get it fixed, but now they are looking to move it. Hard to find someone to water the grass. So measurements also have problems.
That's for sure. In fact, our analysis somehow so we identify, let's put it this way, we identify 15 stations where the somehow the weather data were pretty reliable. We consulted with DWR. We knew Camino as a difficult station because of the little bit of lack of maintenance in that area, but also the forest area. I think this question is from Lynn Wunderlich, right? And so, and I agree with her, the measurements could be very much improved, but we have to start from some basis, and the basis is the assumption that the CIMMYS stations somehow provide reliable information. Now, when you enter this question, it becomes a little bit more sophisticated because there might be a lot of sources of errors or uncertainties, especially, a sensor maintenance, sensor inclination, and, there's so much going on. And I would say probably even the CIMMYS data could be improved with a little bit more effort in close control, quality check, but I know DWR is doing a lot of effort to improve and automate some of the quality check for the weather variables. Yes.
Yeah, and this next question is related to your figure where you were showing the forecast ET compared to the observed for June and July. And the question is, how about forecasted ET in April and May? In the valley, spring weather will be more variable than June and July.
Yeah, I think we did June, July, and August because they're a central part of the irrigation season. And somehow in a wet year like 2019, if I remember well, it was a wet year, the spring rain covers somehow the irrigation requirements somehow is met by spring rain. And so we wanted to focus on in the most critical months also for yield and quality. So the most critical months were June, July, and August for the different specialty crop. This is more, you know, for you know, promoting the adoption of ET-based information for irrigation specialty crop, and the sensitive stages. Most of the crops are June, July, and August. So, but yes, this is a good point. We could have run, you know, for multiple the validation for multiple years, you know, like trying to cover a wet and a dry and average year and see May, June, July, August, and September. But yeah, this is the first step. Maybe some, you know, additional validation work will be happening in the near future. Yeah.
Yeah, more work is needed, right? So, yeah, the next question is tied to the issue of having plenty, right? So now you have open ET data, you have, you know, forecast ET, and you have probably, you know, CIMIS ET, and then there's like, you know, a bunch of others. And the question is, how does your ET data compares to open ET, and then which numbers should we rely on when you have too many options?
I think my take is the you know, to conduct a little bit more ground truthing, more validation work, and try to use, so growers will use what they think is reliable, what, you know, they think is being documented to be reliable, and they've seen some problem with remote sensing, and somehow they're waiting. They're waiting to see whether it's gonna improve in terms of accuracy with respect to. So they basically are in the field, you know, day by day, and they know how much water they apply, especially the educated, very well educated growers, and they see some big differences. We run some tests and some. We did another study using one of the most widely used remote sensing model on pistachio, and the results on pistachio is a different beast with respect to most of the tree and, you know, the tree crops like almonds or table grapes or, you know, other tree crops, and we saw that the difference were pretty substantial in terms of satellite data with respect to the ground-based data. I'm not saying that the ground-based data are 100% accurate, but we kept a very close eye on the maintenance and troubleshooting of the sensor on the ground, and somehow we're pretty confident that what we get is, I would say, more reasonable than was what was predicted in specific timing by this remote sensing based model. So there are crops where things might work better, and other crops that are pretty physiologically sophisticated, and their response to the different drivers of water use might be not straightforward. And so remote sensing is probably very good to spot, you know, problems in the field, or to spot, you know, the spatial variability. But I don't think we are at the point where remote sensing can be used operationally for scheduling irrigation. Not yet. Maybe there's, you know, a matter of years. But I would say ground truthing, validation is the key to make all this source of information reliably usable.
Yeah, okay, so we only have 1 minute and I have 2 questions. So let's quickly wrap this up. So one question, is there a need to update the KC database with more recent studies from the literature, you know, past 10, 15 years, not just doing new studies, but updating the future in an otherwise empty storage space?
Yes, there's definitely the need to update KC values, and this is what we are doing, and this is what, you know, other scientists have been doing the last 30 years. But what happens is when you come up with a new KC set of values, then growers change the variety, change the root stock and the planting density. So it's a never-ending story. You have to start over because, you know, light interception, energy interception is the main driver. And so if these parameters, physical and physiological parameters change, then you have to somehow keep working and refine.
Yeah, and the last question is, I think this is really an important one. It says, and this is something that I certainly, you know, share the same sentiment. The question, I think we still have a problem as an extension agent in teaching growers how to use ET. The feedback I get is too many calculations. Is there any work going on to simplify that?
Well, Fred doesn't have any calculation. You just have a reference ET, and then, you know, you rely on a set of KC value. There are automation and, you know, calculation engines that growers have already in the field. And so most of the educated growers are doing this work, and, you know, they're making also product available to other growers for automating part of the process. And so it's true, there's sometimes based on calculation, but it's also true that technology is very helpful in the field to, you know, to provide synthetic information. You know, the commercial ET station like Thule provide directly ET in inches of water or in hours of operation of your irrigation system. And this is very helpful for growers to implement a little bit with more ease what they used to calculate before.
Well, with that, I would, you know, take a moment to say thank you, Danielle, for this wonderful talk, and we all certainly learned, you know, a thing or two today. And so we do like to announce our next speaker would be Luke Milleron, and he will be talking about orchard system, water management, soil management, and crop management on March 18th, again, starting at 3 p.m. Pacific. So do join us. Thanks, everyone. Have a wonderful rest of the day.
Thank you, guys. Thank you all.
Thank you, Daniele.